Everybody. In this video, we're going to talk about how you can draw pictures of equations because one of the things that helps students understand concepts the best, in my experience, is when they have a picture of what it means in their heads. So for those of you that will teach the upper grades where you start to introduce the idea of solving equations, this idea of drawing pictures of the equations can be really helpful for helping your students conceptually understand the steps for solving algebraic equations. So let's say, for example, that we wanted to represent the solving process of solving 4x minus 5 equals 31 and finding out that the solution is 9. So the process for solving this equation is that you add 5 to both sides, which gives you the 4x equals 36. And then you divide by 4, which gives you the x equals 9. So that's the process we know we could use to solve this equation. And the way that we would show this in picture form looks kind of like this. So first of all, we draw a picture of each expression. So 4x minus 5 means that we have 4 times some unknown number and then we subtract 5. Or you can also think about it as adding 5 negatives. So the way that I would imagine that is I like to think of the x's as being like bags with an unknown amount of things in them, but they're all the same amount of things. So I have 4 bags with x amount of things in them. And then I also have 5 negatives. And then on the other side of the equation, I'm going to have 31 positives. So I'm going to arrange these in groups of 5 because that will be easiest for me to draw. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So that's 30 positives. And then I have 31 positives, so I'll add one more positive here. Okay, so this is a picture representation of my equation. And there's multiple ways you can show that these two expressions are equal. You can represent it with like a little fulcrum teeter-totter looking thing to show that those two sides are equal to each other in weight. Although it is a little bit confusing to think about negative weight. So you can also just like maybe draw circles around the two sides and say these two things are equal to each other. But regardless of how you decide to do it, you show that the left-hand expression is equal to the right-hand expression. And by drawing it this way, it helps the students realize what 4x minus 5 means. It means that you have 4 x's and 5 negatives. And the x's have an unknown number of things in them. And that is equal to having 31 positives. And so when you start solving the equation and you add 5 to each side, well, that means that you're adding a positive 5 to this side of the equation. And it also means that you're adding a positive 5 to this side of the equation. And all of these end up canceling each other out to 0. And that's what tells you that 4x equals 36. Because now I have 36 positives on the right-hand side and 4 x's on the left-hand side. And then my next step of dividing by 4 means that I'm going to divide each side into 4 groups. And let's see, what's the best way to divide 36 by 4? It's going to equal 9. It looks like I'm going to have to maybe divide it kind of wonky like this. But it still works. So I divide both of them into 4 equal groups, and that's what tells me that x equals 9 because one of these groups is going to be equivalent to one of these groups. And so this would be a picture version of how to solve this equation. And when you're first introducing the idea of solving equations, doing something like this can be very helpful for helping the students understand the process of how this is working. And you could also do it with like physical blocks and physical manipulatives, like you could actually have bags. And you could even use that to help the students practice writing equations. You could say, like, if I have these 4 bags with an unknown amount in them, and then I have 5 negatives, and this is equal to these 31 positives, how would you write that equation? And you can also practice that as well. Or you can also have this represented by a word problem, and you can draw the picture to represent the ideas in the word problem. There's multiple different applications of this, but I want to make sure that you guys know how to draw these picture equations because it can help your students conceptually understand it better. So let's do one more example, one that's a little bit more complicated. So in this one, we have 2 times 5x plus 1 minus 9 equals 23. So the way that you would draw a picture for this one is I would start with the stuff inside the parentheses. And I'd say, okay, I have 5x's. So I'll draw my 5x's like this. And then I also have an extra positive, and that is multiplied by 2. So I have 2 groups of that. So probably have to make that a little bigger. So I have another group that also has 5x's in it and 1 positive. And then that also has 9 negatives. So there's 3, 4, 5, 6, 7, 8, 9 negatives. And all of this is equal to 23 positives. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And so this expression is equivalent to this right-hand side expression. And the first thing that I would do to solve this equation is I would get rid of these extra negatives. So to get rid of the extra negatives, I would add 9 to both sides. And this is consistent with our idea of working backwards of order of operations, because if we knew what x was, we would multiply by 5, then we would add 1, then we would multiply by 2, because the set of parentheses is multiplied by 2, and then we would subtract 9. So working backwards, we would add 9 to start solving this equation. And so I'm going to add 9 to both sides of my equation. And if I add 9 positives to one side, it will stay balanced as long as I also add 9 to the other. So here's 5, 6, 7, and then I ran out of room, so I'll just put my 8, 9 up there. Okay, so what that does is it basically cancels out all of these negatives because 9 negatives plus 9 positives will just equal 0 now. So now what I have is 2 times 5x's plus 1, and that equals 32. And so now what I need to do is I need to split this in half. And actually, I think I might move these two over here so it's a little bit easier to split it in half. Because if I split this right down the middle, right here, and let me actually color code this so you can see it. So if I split this down the middle, and I split this down the middle, then this is now equal to this. And that is shown by dividing both sides by 2. And the result is that I have 5x's plus 1 extra positive equals 16. And then what I can do next is I can subtract 1 from both sides. Again, this is staying consistent with working backwards of order of operations because we divided by 2 and now we're subtracting 1. And when I subtract 1 from both sides, I can also think about that as adding a negative to both sides. And when I do that, this positive is going to cancel out, and this positive will also cancel out over here. And what I'm left with is 5x's, which is equal to 15. And then my last step is to divide by 5. Again, that's working backwards of order of operations to solve this. And when I divide by 5 on this side, when I split this up into 5 pieces, I get 1x in each piece. And over here, when I split this up into 5, that gives me 3 positives in each piece. And so that shows me that x equals 3. So that would be one way of solving this equation. Another way is that you could use the distributive property. So what that would look like is if I start off with the same picture, so I have two groups, each group has 5 x's in it. So I'll sketch this out really quickly. So I have 5 x's in both of these, and then a positive 1 as well. And then my 9 negatives, so 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. And this is equal to 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 23. Looks like that. If I were to use the distributive property, I could distribute this multiplication by 2 to both of the terms inside of the parentheses. And basically what that's doing is it's combining all of these x's together, and it's combining these positives together. And what that gives me is 10 x's on 2 positives and 9 negatives. So I just realized I forgot to draw my little fulcrum to show that those two sides are equal. But once I have my 10 x's and my 2 positives and my 9 negatives, then I could combine like terms and combine the positive 2 and the negative 9 to be negative 7. And what that's basically doing is it's taking this positive and negative and making them cancel out to 0. And then this positive and negative and making those cancel out to 0, which leaves you with 7 negatives. Then the next step of solving the equation would be to add 7 to both sides. And that is basically adding 7 positives here to cancel out these negatives. And when I add 7 positives here, that gives me 30 on that side. And all of these positives and negatives cancel each other out. And then what I'm left with is 10 x's being equal to 30 positives. And my last step is to divide both sides by 10 to isolate the x. And so when I do that, basically I'm splitting up these 10 x's into 10 equal groups, which gives you 1 x per group. And over here, when I take all 30 of my positives and I split them into 10 groups, well, I could start off by just splitting them up into 5 groups like this, and then splitting each of those groups up into 2 groups. So that gives me a total of 10 equal groups. And that shows me that 1x equals 3. So one of these bags of unknown amount is equivalent to 3 positives. And so that tells me that x equals 3. So that problem could be solved in 2 ways. You could use the distributive property in combining like terms to simplify the expression on the left before you start solving it, and then work backwards of order of operations by adding the 7 and dividing by 10. Or you could do what I did on the previous slide and just work backwards of order of operations from the beginning. So in either case, you end up with the same answer. This is what the picture equation would look like. So if you have any questions, please let me know, and I hope you have a good day.